Welcome to This Explainer, where we're diving into the largest cosmic impact event in recorded human history. It's this absolute mind-bending mystery that literally took scientists decades to unravel. And honestly, the deeper you look into it, the more fascinating and terrifying it becomes. We're going to explore a very specific morning back in 1908 that completely, fundamentally changed our understanding of the threats just kind of lurking out there in our solar system. 80 million. We're just going to start right there with that staggering number, because that represents the estimated amount of trees flattened in a single devastating moment in the remote East Siberian taiga. Just imagine an entire ocean of dense ancient forest instantly knocked flat to the earth, like a bunch of matchsticks. And the area that covered 2,150 square kilometers of Siberian wilderness just utterly wiped out. To really put that into perspective for you, that is roughly the size of a massive modern metropolis like Tokyo. If this exact same event had happened over a densely populated area instead of the middle of absolutely nowhere, it would have been an unimaginable catastrophe. To really grasp what happened that day, we have to listen to the people who actually lived through it. This harrowing first-hand account from 1908 drops us right into the visceral, just raw terror of what the local Evenki natives and Russian settlers experienced. This guy, S. Semenov, was sitting at a trading post over 60 kilometers away from ground zero, and yet the heat was so intense he felt like his clothes were literally catching on fire. He was physically thrown meters through the air just from the sheer force of the shockwave. Section 1. The Cosmic Crime Scene. The morning of June 30th, 1908. So at exactly 7:17 that morning, witnesses saw this blindingly bright light streaking across the sky. That was followed by a massive pillar of fire, a deafening sound like heavy artillery, and a shockwave that actually shattered windows hundreds of kilometers away. But to understand how this happened, we need to talk about what scientists call a meteor airburst. You see, this wasn't a giant rock hitting the dirt. We're talking about an object traveling at roughly 100,000 kilometers per hour, slamming into the Earth's atmosphere and facing such extreme pressure that it violently explodes midair. This mid-air detonation generated a shockwave equivalent to a 5.0 Richter scale earthquake, and the pressure wave was so massive, it was recorded traveling twice around the entire globe. And the sheer scale of the energy release here, it's just staggering. We're talking about 15 megatons of TNT. That is 1,000 times greater than the atomic bomb dropped on Hiroshima. It's roughly on par with the massive 1954 Castle Bravo nuclear test, or that catastrophic 1980 eruption of Mount St. Helens. The energy was so immense that for days afterward, the night skies across Asia and Europe were glowing so brightly you could literally read a newspaper or take photographs at midnight. Which brings us to Section 2. The First Detective, Leonid Kulik's Journey. Because of the extreme remoteness of Siberia, plus, the massive political upheaval happening in Russia at the time, no scientific expedition reached the site for nearly 20 years. Enter Soviet mineralogist Leonid Kulik. He began this incredibly relentless investigation after finding a random old calendar note about the event in 1921. By 1927, he had finally organized an expedition. He battled the harsh elements, hiked for tens of kilometers, and literally chopped through dense woods for weeks with the help of local Evenki guides. Years later, in 1938, he even managed to secure an incredible 1,500 aerial photographs to truly map out the vast, sweeping scale of all that forest destruction. Section 3. The Missing Crater Mystery. And guys, here is the ultimate plot twist. When Kulik finally made it to ground zero after all that trekking, he fully expected to find this massive, gaping hole in the earth, just filled with chunks of extraterrestrial iron. But instead, well, where was the crater? There was absolutely nothing. No crater. No giant meteor fragments. Just a swampy, incredibly devastated landscape. Kulik was so baffled, he actually tried draining local bogs, thinking they were hidden craters. But nope, he just found old tree stumps at the bottom. But the physics of the blast left a huge clue. It created this massive butterfly-shaped pattern of downed trees stretching across those 2,000 square kilometers. But bizarrely, right at the dead center, the dead, scorched trees were standing perfectly upright. They were just completely stripped of all their branches. This was the smoking gun, proving the explosion happened in mid-air. The blast wave pushed straight down on the trees right at the center, stripping them bare, and then violently radiated outward horizontally, knocking over everything else in its path. Section 4. Modern Clues and Suspects. Comet versus Asteroid. So, without a giant space rock sitting in a crater for scientists to examine, they spent decades debating two main suspects. On one side, we've got the comet hypothesis. Comets are basically dirty snowballs made of ice and dust. And this perfectly explains the missing crater, right? The comet simply vaporized in the upper atmosphere. It also beautifully explains those famously glowing night skies over Europe, which would have been caused by all that cometary dust trapped up there. But on the other side, we have the asteroid hypothesis. This points to a dense, stony, or iron body that exploded due to extreme atmospheric ram pressure, blowing completely apart before it ever hit the ground. So how exactly do you solve a crime with no body? Well, you look for microscopic forensics. Over decades of subsequent expeditions, scientists painstakingly sifted through the soil and tree resin in the area. And they hit the jackpot. They uncovered these microscopic silicate and magnetite spheres. Even more telling, they found high proportions of nickel, nitrogen isotopic anomalies in the peat bogs directly corresponding to the year 1908, and in unusually high concentrations of a rare metal called iridium. These are the absolute classic, undeniable chemical fingerprints of a rocky extraterrestrial asteroid. It heavily tipped the scales away from the comet theory. All of that forensic evidence really laid the groundwork for our modern understanding. And then, in 2013, another meteor exploded over Chelyabinsk, Russia. Now, it was much smaller, but it was heavily documented with modern cameras and instruments. This gave scientists the exact real-world data they needed to run massive supercomputer models. And the results? They perfectly backed the theory that Tunguska was indeed caused by a stony asteroid roughly 50 to 80 meters in diameter, exploding violently in the atmosphere. So, mystery solved, right? Well, the story doesn't end there. Moving on to Section 5, a global wake-up call, the legacy of Tunguska. The whole reason the legacy of Tunguska is incredibly relevant today is because the suspects in our cosmic mystery, they are still out there. And that brings us to Asteroid Day, which is an annual UN-recognized global event held every single year on June 30th. It was founded in 2014 by prominent scientists, astrophysicists, and astronauts, including legends like Stephen Hawking and Apollo 9 astronaut Rusty Schweickart. They intentionally chose this specific date to honor the anniversary of the Tunguska Event. The goal is to map out these cosmic threats and raise massive global awareness before the next big one strikes. And honestly, this is where it gets very real. Out of over 1 million near-Earth asteroids with the potential to strike our planet, we have discovered and mapped about 1%. That means 99% of these potential planet killers are completely undiscovered. We are effectively flying blind through a cosmic shooting gallery right now. So to fix this massive blind spot, over 22,000 citizens and experts signed what is known as the 100X Declaration. It lays out 3 really critical steps for planetary defense. First, we desperately need to employ the technology we already have to detect and track these threats. Second, we must accelerate our discovery rate 100-fold, aiming to find 100,000 near-Earth asteroids every single year. And third, we need global adoption and awareness so governments actually take this planetary defense seriously. Which leaves us with this final, kind of unsettling thought. We have mapped just a tiny fraction of what's out there. The 1908 Tunguska impact leveled an area the size of Tokyo, and the 2013 Chelyabinsk meteor injured over 1,000 people. And remember, neither of them even left a crater. So as we continue looking up at the night sky, we really have to ask ourselves, when exactly will the next Tunguska arrive? And more importantly, are we finally going to be ready to find it before it finds us?